Hi guys, good evening, morning, afternoon. So we are going to continue with yesterday's lecture. We had completed the first part of this chapter, square and square roots for class 8 ICSE. We'll be continuing with that. We have done 27 slides. So last class we have done till here. Okay, we have understood this sum, read the question well, then utilize the concepts that we use to make sure we understand what are the how to solve this sum step by step. Let's continue with the next sum now. So this question is a very important question. As you can see, the question states that find the smallest perfect square number divisible by 24, 30 and 60. 24, 30 and 60. Okay, the question states that we have to find the perfect square number, smallest perfect square number that is divisible by, so 24, that whatever number we have to find, that number should be divisible by 24, 30 and 60. Okay, so let us do it step by step. First thing, let's write 24, 30 and 60. Okay, I'm doing one thing separately in order to make sure to understand what are the different numbers that are present in this. Okay, first thing is that, so 24 can be written as, one second, 24 divided by 2, 12 divided by 2, 6 divided by 2, 3. So 2 to the power 3 into 3. What about 30? 2, 15, 3, 5. So 2 into 3 into 5. Next 60. 60 is nothing but this into 2 will give us 60, right? So this is going to be for 60. Okay. So for 30, it will be 2 into 3 into 5. So let's first do one thing. Let's write all the numbers down. Okay. So 2, let's find the LCM of the number first. Let us decide after that what will we find out. So LCM here is what? 2 to the power 3 into 3 into 5. Okay, so this 2 ones are 4, 8, 8 into 3 into 5. So 24 into 5. 24 into 5 gives us 120. Okay, so the least number, if we have found out that all of these three are divisible by what least number, it is 120. But we have to find the smallest perfect square. Smallest perfect square. Okay, so 120, we have to multiply 120 with any number that should give us a perfect square. Okay, so let us continue. Like you understood the basic, if the question would have suggested that what is the largest common multiple of that number, the answer will be LCM will have been 120. Okay, now let's find the perfect square of that number. So 24 2 to the power 3 into 3, 30, 2 into 3 into 5, and 60, 2 into 3 into 5 to the power 2. Okay, so in order for this to make it a perfect square, we have to multiply it by 2 into 3. Okay, in this case 2 into 3 into 5, in this case 3 into 5. Okay, now let's see what is coming. 2 to the power 4 into 3 square, 2 to the power 2 into 3 to the power 2 into 5 square. Lastly, 2 to the power 2 into 3 to the power 2 into 5 square. So this and this are same, more or less. Okay, so let's solve this. 4 into 9 into 25. So it's coming what? 100 into 9, 900. Okay, now for this. Okay, so it is going to the power 4, 2 ones are 2, 2 2s are 4, 8, 16. 16 into 9 gives us 9 6 are 54, 9 ones are 9, 10 11 12 13 14. 144. Okay, so now we have to find out what is going to be the multiple of these two numbers so that it is a perfect square. Okay, let's see. 96 multiple is what? 1800, 2700, 3600, then comes 4500. Now, as you can see the multiples of 900, so can you tell me what is going to be a number which will divide both 144 and this? And as you can see, this is also a square number, like perfect square. This is also a perfect square. So among this, all the multiples which are present, what is the perfect square? Can you find out? Is 4500 a perfect square? No, it's not. Is 3600 perfect square? Yes, it is. Is 2700 perfect square? No, it's not. It's 1800 perfect square? No, it's not. Now, last thing of the sum is 3600 divided by 144. Let's find it out. So 3600 divided by 144. 36 is what? 12 into 3 into 100. And this is what? 12 into 12. Okay. So 144. So 144 into 25 will give us, okay. So we have found out the answer. The answer is 3600 in this particular sum. Okay, so this is the most basic common method in order to do that. But in case in your exam, if you want to solve this kind of sum, the step that I use is this. Did you understand? Okay, now the shortcut method to do this sum. What shall we do? Okay, we know perfect squares. Okay, so first is find the LCM. 120. Okay, now LCM of this is 120. 24 के सामने what is the least multiple of 24 that will be a perfect square? Okay, what will be a least multiple of 30 that will be a perfect square? 60 that will be a perfect square. So first thing that we will do, 24, 30, 60. Okay, okay, so I'm telling you how to find the LCM directly from also this we can find out. So 5, 2, 1, 1. So this is 10, this is 6, and this is 2. Okay, so we also get 120 here. Okay, so LCM directly you can find out like this if in case you forgot what is this. Okay, so let's see all the perfect square. Let's write it down. Okay, what we know, not something that we do not know. Okay, so let's write down. So we know it cannot be lesser than 60. तो 120 से ज़्यादा greater than 120 क्या perfect square होता है? So 169, then 196, like that it will continue. But we already know is 1000 is not a perfect square. It is 10 to the power 3. It's a perfect cube, not a perfect square. 2500, this is a perfect square. Why? 5 square into 10 square. Okay, similarly like that, 36 into 100, 6 square into 10 square. This is a perfect square. Now I will check whether this 36 into 100 is getting divided by 120. If it is perfectly divisible, 12, 12, 3, 30, it is completely divisible. So 3600 is the answer. Okay, this is the shortest step that we can do. Okay, now let's see the answer. Okay, as simple as that. Okay, so LCM of this number is 120. 120 is equal to 2 into 2 into 3, 2 into 3 into 5. Now this particular portion, 120 divided by 230 divided by 215 divided by 3, 5. Okay, so 2 into 2 into 2 into 3 into 5. So these two makes up a pair. So these three numbers are the numbers that are left. Okay. So in order to make it squares, we have to multiply this entire thing with the same numbers. So 2 into 3 into 5. Okay. Thus we get the answer 3600. Okay. I think it is very clear now. And this method is also very useful. It is also very neat and tidy. Chalo. Now some interesting patterns. Let's find it out. Numbers between consecutive squares are 1 is 1 square, 2, 3, 4 is 2 square, 5. Oh, we have already found out this. Remember, I have told you one thing. For example, 25 and 36. Okay. 25 is 5 square, 36 is 6 square. Okay, the 25 is 5 square, 36 is 6 square. The number of digits between these two is what? So 2 into 5. What is 5? 5 is the lower of the squares. So there should be 10 numbers between them. Let's find it out. So 25, 26, 27, 28, 29, 30, 31, 32. 33, 34, 35, 36. Okay, so between 25 and 36, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have already found out 10. Okay, this is how we find the number of non-perfect numbers between two perfect squares. Okay, sure. Same thing. Okay, now we shall watch a video on how do we find the square root of a number using the prime factorization method. Okay, I think this is the most useful method that we do in our daily life in sums and questions, so that we answer all the solutions. Let's watch the video. How do we find square root of a number using prime factorization? Let's give it a watch, guys.
The easiest way to find the square root of any number is to use a calculator. But if you're asked to find the square root of a number without using a calculator, there are two ways in which you can do it. The first method is phenomenally simple. It's called the prime factorization method. We will look at the second method in the coming videos. If you have watched the previous video, you should be familiar with what square roots are. So we can look at square roots of slightly larger numbers in this video. So we want to find the square root of 225. Our aim is very simple. We have to reduce this number to its prime factors. That's all. How do we do it? Before we go ahead, let us revise what prime numbers are. A prime number is a number which is divisible only by itself and 1. Say 5. 5 is divisible by 1 and is divisible by 5. There is no other number which can divide 5. 1 and itself. Hence, it's a prime number. Let's consider 8. 8 is divisible by 1, 2, 4, and 8. Apart from 1 and itself, it's also divisible by 2 and 4. Hence, it's not a prime number. So let us start reducing the number 225 into prime factors. Prime factors are factors of this number which are prime. We can write 225 as 5 multiplied by 45. 5 is prime, but 45 isn't. So let's reduce 45 further and write 225 as 5 times 5 times 9. We wrote 45 as 5 times 9. 5 is a prime factor, but 9 isn't. 9 can be written as 3 times 3. Hence, 225 can be written as 5 times 5 times 3 times 3. In this way, we reduce 225 into its prime factors. This was simple, but is it the quickest way? No. Let's look we write the 5 here? We just write the prime factors in this column. 5 multiplied by 45 gives us 225. 45 is not prime. Hence, we continue with this process. 45 is also divisible by 5. Hence, we write a 5 here. And 5 multiplied by 9 gives us 45. 9 is not prime. And we can say that 3 multiplied by 3 equals 9. That's where we start. Where we get a prime factor here. So if we look carefully, we have got all the prime factors. 5 times 5 times 3 times 3. Why do I say this method is faster? Look at the first 5 in this method. We continue to write it every step. Then we repeat the 5 times 5 we got in this step in the third step. Many of the numbers are repeated in every step, and hence there's a bit of a redundancy. If you really want to know how tedious this method can get, try reducing 216 into its prime factors. By now, we should be fairly comfortable with prime factorization. But now we get into the most important point. How would this help us find the square root of 225? You will not believe how simple it is. We write this as square root of 5 times 5 times 3 times 3. We have to make roots of two same numbers. This can be our first root, 5 and 5. We can make another root, 3 and 3. We basically form pairs of same numbers. So we have two pairs of same numbers here, 5 and 5 and 3 and 3. Once we form pairs, to find the square root, all we have to do is pick one number from each pair and multiply them. So from the first pair, we pick 5, and from the second pair, we pick 3. And we multiply 5 and 3, which gives us 15. At first, this seems long, but with practice, it gets very simple. Hence, we can say that the square root of 225 is 15. All we did is to run the number to its prime factors, make pairs, choose one number from each pair, and multiply them. In the next part of this video, we will see how we can find the square root of 11,025 using this method.
Okay guys, so before going on to the next video, okay, I think let's solve the number that was given by them, 11,025. I think. Let's see, 11,025. Okay. First thing, let's check whether it's divisible by 3 or not. 2 is divisible. This is not divisible because the last number is not even. So let's see divisibility rule of 3. 5 plus 2, 7, 8, 9. So yes, it is divisible by 3. So 3, 3 threes are 9, 9, 10, 11, 20, 5, 6, 18, 27, 15, 5. Okay. Again, let's see whether it is divisible by 3. Yes, 12, 12 plus 6 plus 3, obviously divisible by 3. So 1, 2, 2, 5. Okay. Now let's see for this 5, 6, 7, 8, 9, 10. No, it is not going to be divisible. So let's go for 5. 5 twos are 10, 20, 4, 5. Again with 5. 5 fours are 9. Then with 7, 7 sevens are prime factor. So 3 into 3 into 5 into 5 into 7 into 7. Whole of this under a radical, okay, or a square root. Okay, so let's make the pairs now. 3 ka pair, 5 ka pair, 7 ka pair. So this is 3 square into 5 square into 7 square. Okay. So we get half into 5 to half into 7 square to half. Okay. So this get cancelled out, cancelled out, cancelled out. We get the answer as 3 into 5 into 7. Okay. So 3 into 35, 15, 1, 9, 10, 105. Okay. So 105 का square will give you 11025. Okay, I think we, like, no point or no like reason watching the video again. So let's continue the next part. That is finding. We have already found out how to find the square root of a number using prime factorization. Okay. Now it's time for using long division method. It's just written division here, but it's actually not division. It's going to be long division because it will keep on going. Okay. Chalo. Let's find this, how to solve this method. Let's take this number only, what is given here. Let me take a fresh board. The number is 276676. Okay. What shall we do? Let's follow the steps. First, they are telling me to starting from right to left, we'll take pairs. Okay. So 27666. Right to left pair. One pair, two pair, three pair. This is first pair, second pair, third pair. Okay. Left to right, left to right, left to right. Yeah, left to right, right to left. Okay. Chalo. Now, first we'll do this. This. We already have the square with us. Okay. So 27. What is the square root that is nearest to 27? We all know that is 5, right? So we'll write 5 here and 25 here. Minus, okay, okay, minus 25, 26, 27 to 2, 266. Okay, so after this, doubling this, whatever this is, so this is 5 here, right? So 10, 5 ka double, 10. So what do we multiply 100 and, see, 100 and, for example, it is 2, 102 into 2, so 402. This is the closest from this, right? If I do 103 into 3, it will give us 903. So 309 ho ja raha hai. This is 266, so this has to be this number. It will be 102. Okay, here it will be 2 again, and here it will be 204 that we found out. Okay, so 6. Now here it will be 7 6 again. Okay, so 52 ka double 104. So 104 into what will give us this number? Let's find out. 104, let's see if it's, we divided by 6 and 6 again. So 36, 24, 27, 2, 2, 6. 6 to 7 is 6, 6 to 7 is 6. Here it will be 6. Here also it will be 6. Okay. So 6 to 7, 6 minus cancels out. So 526, 526 का square करने से we'll get 276676. Okay. So there is a video attached to this particular section as well. If you did not understand this, we'll watch the video again. We'll figure it out. Okay. So this are all the steps. Okay. So let me repeat whatever I said. 5, 27, 66, 76. 3 pairs we have done from right to left. First 27. 27, the lowest square of what? Perfect square of what? 27 से कम होगा तो 25 5 का, तो 5 5s are 25. 25 minus 2, 5 का double 10. Okay, 10. 10 in 102 into 2, 204. 52. 52 double 104. 104 into 6, 6 to 7 6. That's okay. Okay, let's find these out using division method. Okay. See, whenever questions like this come, it is, unless and until it is stated here that find using division method. See, the first one I'm doing by division method, second one I'm doing it by normal square, like square root method. Okay, how to do this? Let me do the second one. 729 divided by 1, 2, 3, 4, 5, 6. 10 to the power 6. Okay, 10 to the power 6. 729 is what? Let us find it out by the method that we already know. What is the prime factorization? So 3, 3 2s are 4s are 3s are, again 381. This is 9 squared, so 9 into 9. Okay, so 9, 9, 3 into 3. So this is 27. 27 square will give us 729. Okay, so 27 by 10 to the power 6 square. This has a root. Okay, so 27 square into half, 10 to the power 6 into half, 327. So 27 divided by 1000. So the answer will be 0.027. Okay, this is going to be the answer for the second one. Okay, what did we do here? Simple prime factorization method. Now let's solve the next one using division method. Okay. 605.16. From the right, pair, 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 pair. If there is nothing here, add a 0. Okay, make it a pair. Okay, first 6, 200, 2 twos are 4. So first write 2 here, 2 here. This is 4 minus 2. Bring this to 2 per double 4. Okay, so 445 into 5 gives us how much? 2022. 44 into 4 gives us how much? So this is what we have to go. So 4 here, 4 here, 176. 24 to 2, 48. So 486 into 6, 36, 48, 51, 24, 24, 20. So the answer is 246, 24.6. Why did I write the point here? When I will, this point will come down here. If there is a point here, whatever digit that we are writing here, that is 6, उसके पहले point होगा, तो 24.6. Okay, you get it, guys? Okay, this is how we solve it by long division method and by prime factorization method. Okay, 24.6 and 0.27. Okay, now comes this kind of sums where you have to find the square root of 24.729 correct up to 2 decimal places. This 2 decimal places concept is very important. Let us find it out. So 24.729. Okay, 2, 2, 1. Okay, add a 0 to make it a complete thing. First is 1, 1, 1 here, 1 minus 24, 7. Okay, okay. So, like before doing it like this, let me teach you a very easy method. So, like that is an assumption method. Like, should I do it first or no? Let's do it now only. So, this is very near to 25 per square, right? Very near to 25 per square, right? So 24.729 is very near to 25 per square, but it will be lower than 5, right? 5 से कम होगा this. Okay, so this gives us an idea the answer is going to come 4.9 something or something like that. Okay, let us do it. 112 E4 E4 7 29 5,000. Okay, so this, let me do this first. One second, there might be something wrong with the sum. If I'm taking this as 2, okay, so this is what was wrong with the sum. 7 to 9, I have to give the 0 to the right hand side of the sides. Okay, so let's check this, what they have done. So 24, 72, 90, and double zero. Okay, so firstly, this particular portion is comes after the sum when we are going after first or second unit. But see, the answer is more or less less than 5, right? So I've already told you 4.9 something hoga. Okay, let's see. So 16, 4, 4 ka double 8, 8 into 9 gives 801, 49, 49 into 2 will give us 98, 98 into 7, then 497 into 2, 994 into 2. This will keep on continuing. Okay, so this is the answer, correct up to 2 decimal places. Okay, chalo, let's continue. Find the least number that has maximum be subtracted from 243 so the remainder is a perfect square. Okay, chalo, let's see. Find the least number that must be subtracted from so that the remainder is a perfect square. So 2433 minus x, that is the number, will lead us to a perfect square. Okay, this is what is written in this. So let's find out what is the closest perfect square to this number. Okay, so we know that 2500 is the perfect square of 50. Okay, 2400 is a perfect square of 50. Okay, now let's find something. Can you see, guys? So 2543, 2433. Okay, so let's find out for 49. 49 square, 49 square with 9 square is 81. 4 square is 16. 4 into 9, 36. 36 into 2, 72. 1, 0, 1, 14. 2401. Okay, so 49 square gives us 2401 and 50 square gives us 2500. The question states that what should be subtracted in order to make it a perfect square. So we are not going to be using this because this number, this is bigger than this number, right? So it cannot be subtracted from anything. So we'll subtract this from this. Okay. So it will be 2433 minus x will give us 2401. Okay. The value of x will be 2433 minus 240. So when 32 is the answer. Okay. Okay. 32 is the answer. And the answer is 49. Chalo. Now find the least number that must be added. The last one was subtracted. Now this is added. Okay. Chalo. We are using, last time I did it directly. Now I will be using long division method. So 18265. Okay. So this 1 second. Like I tend to not use long division method as long as it is not required. So 3, 15, 16, 17, 18, 32, 32, 6, 5, 3, uh, 5, 3, 15, 1, 24, 26. This is fine. Now from this 20,418, one thing. 5, the last will be 5 only, 180, 162, 169, 196. This is 30. So 135 whole square will give us 25. 13 square is 169 into 13 into 5, 13 into 5, 65. 65 into 2 will give us 10, 12, 13, 130. 135 to 12, 1678, 18225. So we have to, so the closest square, that is 135 plus square I got. That is the closest to this. Now what did I do? How did I do it? I'll explain everything to you. Okay. So 18265 minus 18225. 0, 40. So 40 should be subtracted, but here it is written added. Okay. So next term, we have to find the next term. What is the next term? 136 ka whole square. Okay. So 6 will give us 36. 13 will give us 169. 13 6 are 13 6 are 78. 78 into 2 6 14 156. So 156, 6, 9, 14, 1781. Okay. So 18265 minus 132. 231 should be added and 40 should be subtracted for this particular cell. Now what did I do? I took this particular number, the one that is required. Okay. See, this long division method, everything will be taught by school, but this particular method that I'm going to be teaching you right now, something that is not taught in school, because these are all shortcuts and tricks in order to make sure you understand this. So let me first head dive into this particular question. Okay. So the answer is 231 and 40. Regarding you must be added, to add it is 231, subtracted is 40. So what did I do now? 18 to 65. Okay. First thing I do, square hoga na. So I am breaking it into two numbers. Okay. 65 and 182. So if there is any square and the unit digit of that square is 5. Okay. So the answer has to be nearby 5. Okay. So I'm writing just, I wrote down just 5 here, because can you see 15 square is 225. 25 square is 625. Like that, you have an idea. Unit digit is 5, square, the nearest one should also have something like 5 only. Now from 182, what is the nearest square numbers to this? 13 square and 14 square. Okay. Always take the lower number. 160, 160 what ka square? 13 square. So I got the number 135. Like that, I got the number 135. 135 is the nearest to this, and the second number 135 is nearest, 136 is the next. So 136 square, I found out the answer, then I subtracted it to find what number should be added. Okay. But this method you can also use. Okay, simple. 1 1 82 69, 13 ka double 26, 26 into 5 135. So you get the number like this. So 40 here, 40 again, what is what difference that we have found out. So if 40 is the difference, then 1496, that is the next one. 136, we have to find out the 136 square minus whatever is there in the question. We can, what number is to be added. Okay. Now properties of square number. A few properties are present. Okay. First is 11 square. So 1 as the unit digit, let me write it down so that you can understand this very well. Okay. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I will let 0 here. Okay. So any square ending with 1 will have the unit digit as 1. 2 ka unit digit will be 4. 3 ka will be 9. 4 ka will be 6. 5 will be 5. 6 will be 6. 7 will be 9. 8 will be 4. 9 will be 1. 0 will be 0. Okay, that is what is written here. 1 ends with 1 always. 4 ends with 6 always. 8 ends with 4 always. 2, 4, 3, 9, 0, 0, 5, 5, 6, 6, 7, 9, 9, 1. Okay. If you don't believe me, let's do a number. Okay. If I say uh, 23 square. Okay, so we know 3 ka last digit 3, as 3 is there, let's find out what is there. 3 last has to come 9, right? So let's do it. 23 ka square. 3 is 09. 2 is 04. 2 into 3 6. 6 into 2 12. So 9 2 5 529. Okay, if you want you can also calculate in normal method like 23 into 23. 23 into 23. Okay, next. Next, we have the second property. So this numbers, like we have already found out some numbers, right? We have already found out that if 1 is coming at the end, okay, 3 is coming at the end, no, 3 won't come at the end. So 1, 4, then 5, 6, 9 and 0. If this numbers are any like a big number, okay, if it's ending with any of the 6 numbers, it might be a perfect square. But if it is ending with 2, 3, 7 or 8 at the unit place, it is never a perfect square. Okay, next. If 1 or 9 is in unit space, for the square of this number always has 1 as unit space. Okay, already discussed. 4 and 6 will have 6, already discussed. Square will have 6 in unit space, already done. Now, how do you find the square root of a number using long division method, part 1. Now, the video I was talking about long division method, let's find it out. Using long division method, this is by prime factorization, done. This is by long division. Let's start. Okay, there's a very big video, as you can see. I'll try to play it a little bit faster. You can slow down the speed if you want to.
There are two ways to solve for the square root of a number. We can either use a calculator, of course, everybody would love to use this option, and the other way is to solve it manually. Manually too, we can solve it in two different ways. One, by using the prime factorization method, which we have already seen. We split the number into its prime factors and then choose one number from each pair. The other method, which we will look at in this video, is called the long division method. The name sounds fancy, but don't worry, if you follow the steps given in this video, you will never go wrong. But why can't we just use prime factorization every time? Well, if the number is large, it will take us a lot of time to reduce it with prime factors, and the chances of going wrong are very high. Hence, prime factorization is useful only for small numbers. And for large numbers, we can use the long division method. Let's solve a couple of examples to understand how the long division method works. Look at the number 8,281. If we have to reduce this number to its prime factors, we would first have to think of all the divisibility rules and so on, and that would take us a lot of time. So for such large numbers, we use the long division method. The first thing we need to do in the long division method is to draw lines like this. A line on top and a line on the left of the number. When you draw a line on top of the number, remember to leave some space above the number. Once you're done drawing these lines, you're ready for the first step. The first step is to mark pairs of digits from the unit's end. The unit's end is the number 1. So we mark pairs of digits from the right hand side. This becomes our first pair from the right, the number 81. We continue to mark pairs till we cover all digits of the number. The next pair will be 82. So the first step was simple. We just mark pairs from the right, which gives us two pairs, 82 and 81. Now we look at the first pair from the left, which is 82. In the second step, we have to find the perfect square, which is equal to or lower than 82. Since 82 is not a perfect square, we choose the perfect square lower than 82. The perfect square just lower than 82 is 81. Even 64 is a perfect square lower than 82, but remember, we always choose the one which is closest. We know that 9 squared equals 81. We just found out the most crucial number. It's the number 9. 9 is basically the square root of the closest perfect square. We write the number 9 here to the left of the number. This was actually the most important step of the log division process, to find the first number. The next step is one of the easiest steps, but it's a step where most of the students get confused. The step says multiply above and add below. But what do we multiply and what do we add? It's the same number, 9. Let's focus on multiplying above first. We multiply 9 with 9 and write the product here. So the 9 you are multiplying is written on top. Now let's come to add below. We add 9 with 9 and write the sum underneath. 9 plus 9 gives us 18. We multiply the same number with itself above and wrote the product here. And we added the same number with itself and wrote the sum here. Remember, when we multiply or add, we bring the operation with the same digit. In this case, it's 9. So we have completed 3 steps. First, we found the pairs from the right. Second, we found the perfect square and wrote its square root here. Third, we multiplied above and added below. If you observe it well, you will see that I have left some space next to the sum of 9s. That space is kept for the box. So we draw an empty box here. And inside this box, we will be writing some digit. Our next aim is to find this digit. The next 3 steps are super simple. We just subtract the product from the number above it. The product we got was 81. The number above it is 82. We subtract 81 from 82 and get 1. And then we get the next pair down. The next pair is 81. So we write it next to 1. Then we draw the same box above and below. Above, we draw it next to 9. And below, we draw it under the original box. The digits contained in each of the boxes are the same. The next step, according to me, is the most interesting step of the log division method. We use trial and error to find the digit in the boxes. We look for the product of two numbers, which gives us 181. This is how the product should look. What number do you think we can write in the boxes to get 181 as a product? Remember, the digits in both the boxes have to be the same. Yes, 181 multiplied by 1 gives us 181. So we found the digit in the boxes, it's 1. After we find this digit, we go back to the third step and follow the same procedure. Multiply above. So we write a 1 and a 1 in these two boxes and get the product of 181 and 1 as 181. Then we add below. We add 1 to 181 and get 182. Then we subtract the product from the number above it. So we subtract 181 from 181 and get a 0. The moment we get a 0 here and there are no pairs left, we are done. But wait, where's the square root of 8281? Well, it's the number you got on top. It's 91. The square root of 8281 is 91. Trust me, it's not difficult. It's just a little lengthy. Let's review what we just did. We marked pairs from the unit end, which gave us two pairs, 82 and 81. Then we choose a perfect square which is equal to or lower than the leftmost pair, 82. We found out that 81 is the closest square. We write its square root to the left. Then we multiply above. 9 multiplied by 9 equals 81. And add below. 9 plus 9 equals 18. And with 18, we leave space for one more digit. Then we reach the 3 simple steps. First, we subtract the product. 82 minus 81 gives us 1. Second, we get the next pair down. And then we draw the same box above and below, which will contain the same digit as the original box. And to find the digit in the boxes, we use trial and error and write 181 multiplied by 1 as 181. So the number in the box will be 1. After we find the number in the box, we go back to the third step. We multiply above. 181 multiplied by 1 gives us 181. Then we add the same digit below. 181 plus 1 equals 182. Then we subtract the product. 181 minus 181 gives us 0. And since there is no pair left, we stop and get the square root as 91. Remember, inside the two lines, we always subtract, and outside, we always add. To get a better idea, see the second part of this video, in which we have solved for the square root of another number using the same procedure.
Okay guys, I hope that helps. Okay. So let's continue. We are not going to watch any more videos. It's about the same sums. Okay, we have already done this. This is done. This is also done. Done. Okay, now this is something that is really important. The one where I used like did it with prime factorization method. No, So this particular portion is very important. This is probably going to be the last video. Okay, so just this is the last video, guys. Do take care of this particular sum because this is going to be very important. Finding square root of an integer in which there is a decimal point.
Method to find the square root of the decimal number 176.89. We will draw two lines, one to the left and one on the top of the given number. In the given decimal number, 176 is the integral part and 0.89 is the decimal part. The steps to find the square root of a decimal number by long division method are similar to finding the square root of an integer. The first step in finding the square root of a decimal number is to mark pairs before and after the decimal point. So first we put bars on the integral part of the number 176 in the usual manner, starting from the units place close to the decimal, which is 6, and moving towards the left. Hence, we put the first bar over 76 and then a tiny dot over 1. Now, for 0.89, we start from the decimal point and move towards the right. Hence, we put a bar over 89. Now, just for understanding purpose, suppose that we had 3 digits after the decimal. In such a case, we will put the first bar on the numbers 89. Then for the second bar, we put a 0 on the right of 1 and make it 10. Then put a bar on it. So in this way, we mark pairs in the decimal part. Now coming back to our original number, which is 176.89, we can see that after the first step, the number is divided into 3 parts, 1, 76 and 89. In the second step, we have to look for a perfect square, which is closest and lower than the first part, which is 1. Now, 1 itself is a perfect square, so we can write 1 next to the number. In the third step, we multiply 1 above and add 1 below. So 1 multiplied by 1 is 1, and 1 plus 1 is 2. Since there are more pairs left, we need to draw a box next to this 2. In the next step, we subtract 1 minus 1 and write the result, which is 0, below. Now we have to bring the next pair, 76, down. And then we draw the same box above and below. As we've seen in the previous videos, the digits contained in these 3 boxes will be the same. And to find that digit, we will use trial and error. So, on trying with number 2, we get the product of 22 and 2 as 44, which is very less than 76. So, we will try the number with 3. On doing so, we get the product of 23 and 3 as 69, which is the closest to 76. So we add 3 and 23 to get 26, and subtract 69 from 76 to get 7 as the remainder. Now, we get the next pair down, which is 89. Here, this 89 is preceded by a decimal point, hence we will put a decimal point after 13. Now again, we need to draw the same box above and below. Next, we need to find a number by trial and error such that the number so formed is closer to 789. Now, if we put 3 on the side of 26 and multiply 263 with 3, we get 789, which is equal to the number that we need. So on subtracting, we get 0, and on adding 263 and 3, we get 266. This number on top, 13.3, is the square root of 176.89. We can even verify our answers as we did in our earlier videos by comparing the numbers 266 and 13.3. If we ignore the decimal point and multiply 133 with 2, we should get the number 266. Here, 133 multiplied by 2 is 266. finally say that the square root of 176.89 is 13.3. And that's how we find the square root of a decimal number using long division method. Now, using this method, find the square root of 156.25.
Okay, try to do this. Okay, 156.25 का square root using this particular method, and write the answer down in the comment section. So this square root of 30, square of 30 is 900, square of 300 is 9, two zeros again. That is it. So now a perfect square number leaves remainder 0 or 1 on dividing it by 3. Okay, 9 is a perfect square number and dividing it by 3, remainder is 0. 16 is a perfect square number, dividing it by 3 leaves the remainder 1. So 0 or 1 will be the only remainder when it is divided by 3 with the perfect square numbers. Okay, now this is a very important property. For a natural number n plus 1 whole square minus n square will give us n plus 1 plus n. Now what is this all n is about? Okay, let's find it out. Let's take natural number, let's take 2. So 2 plus 1 whole square minus 2 whole square is equal to 2 plus 1 plus 2. So 2 plus 1 is what? 3. 3 whole square is 9 minus 4, 5. This is also be 3 plus 2, that is 5. Okay, this is nothing but a plus b, a minus b. A plus b, a minus b, a square minus b square. Nothing else but this, which I think you have already done this in algebra, but it's the same thing. So I think so we learned in this chapter what are squares, how to find squares, what are square root, how do we find square root, how to find square root using prime factorization method and using long division method, what are the tricks to find out square root, how can you get an idea what is the closest square root that we have to find out. Okay, so thank you for your time. Hope you had a good session. If you have any issues or any problem, do write it down in the comment section. Okay, happy learning guys. Bye bye.